Hey everyone, welcome back, and let's write some more neat code today. So today let's solve number of atoms. Before we start, I just want you to know that if you're watching this video right now, you're a very brave person, and honestly, I have a lot of respect for you. I probably shouldn't show you this right at the beginning of the video, but this is the solution I'm going to code up in this video. You might think, well, that's too small for me to read, but as you can see, this is the only way I can fit all of it on the screen. Getting rid of the comments, I think it's still almost 40 lines of code, and that's using Python. So for all you folks that are using Java, I think you'll be able to understand the solution. It's a lot of code, but it's not as complicated as it looks. I honestly think you'll understand 100% of this by the end of the video. But if you're a Java person, I have a lot of respect for you. You're going to have a very fun time probably trying to translate this. Your solution will probably end up being double the length. So if you ever want to join the Church of Python, feel free. I've got some courses if you want to learn it, but obviously there are many ways to learn Python if you'd prefer to learn it a different way. As always, long description. I'm going to try to summarize it for you. Mainly a chemistry problem. And the idea is that periodic elements in chemistry, usually they're one letter, like many of them, hydrogen, oxygen, I don't know the other was, to be honest. I think carbon is just a C. Some of them can have multiple characters, multiple meaning two. So at most 2 characters is what an element could be. So you kind of have to know that. I wish they said it in this problem, but I mean, let's be honest, the problem is long enough. But helium, I think this is what this stands for. I won't try to guess any of the others. Actually, I think Mg is magnesium, but you get the idea, right? The ones that are of length 2, the first letter is going to be capital and the second letter is going to be lowercase. That's the only way we can distinguish between something like this. And imagine you have an M and a G. I don't know if there is a periodic element that stands for G. You know, this is one element, this is a separate element, and this here is just a single element. So how would you be able to know? Well, we can distinguish this is uppercase G, this is its own element, this is a lowercase g, it's a part of the preceding element. So Mg is a whole unit. Now, every element is going to start with an uppercase character, so that's simple. Like, we're going to be dealing with uppercase characters, we're going to be dealing with lowercase characters, but they're always going to belong to an uppercase character. There's one more thing we're going to be dealing with, well, actually a few more things. A number. Imagine the number 2 comes after helium. That means there's 2 units of helium. There's 2 instances of this element. I'm sure you know what this stands for, H2O. 2 instances of H, 1 instance of oxygen, and then you get water. We might not just have a single digit. Usually it's just a single digit, but I mean, imagine there's 10 instances of hydrogen. So we have to kind of keep track of that. Like, you're gonna need to check for this character. Like, it's always gonna start with an uppercase character. For now, let's assume we're always starting with an uppercase character, because that makes it kind of easy for us, right? So after, there could be a few possibilities. It could be a lowercase. That would mean that, okay, well, now we reach the base case. Base case meaning, okay, now this is the element. Or, you know, it could be another uppercase that comes after it, which means, okay, this was the base case, that's its own element, and now we have another element that, you know, there might be a lowercase character after that or something else. The other case is where there's a number. Now, if there's a number, there could be more than one number. So we kind of want to find the last digit. And once we find that last digit, now we found the base case. I'm probably not using that term correctly, but basically what I'm saying is we found that unit. Now we've stopped, right? Now we found that group. Because H by itself, if there's a number coming after it, that's not good enough for us. We need all the numbers that come after it. We need to know how many hydrogens there actually are. So you can see that there is potentially a solution here that is a recursive solution. This is kind of reminding me of a state machine. And I think there is a solution like this from what I looked at the Leetcode editorial, but I think this solution honestly is even longer to code up than the one I implemented myself. And quite frankly, I think it's harder to understand, and I don't want to be here for like a 1-hour video. If you want me to start making 1-hour videos, let me know, but I try not to make it longer than 30 minutes. And I think it's going to be difficult enough to keep ourselves in the time limit explaining the solution I'm going to show you. For that, the intuition is going to come from the other case. There's actually one more case that could be added to these. We're dealing with lowercase, uppercase, and numbers. We're also dealing with, to make it even more difficult, parentheses. But actually, the fact that there are parentheses leads us to an optimal solution. This is the intuition. There could be nested parentheses. Let me show you a formula. They were very kind to give us these 2 examples. Take a look at the first one. It's a bit more simple. We have the element Mg, we have a parenthesis, we have two elements inside of it, oxygen, hydrogen, and then we have the number 2. Now, these parentheses are sort of shortcuts. It's a shortcut of saying Mg, O2, H2. So basically, kind of like multiplication, this 2 will be distributed among everything inside of the preceding parentheses, so the preceding closing parenthesis. I guess I should probably explain quickly like what we're ultimately returning, because I sometimes forget to do that, but I assume you guys know how to read, so I'm assuming you probably already read the problem description before watching this video. If not, let me know if I should go through what the question is asking for at the beginning of the video. But the idea is we basically want to find the count of every single element, the count of it, and then we want to return it in the form of a string that looks like this. But that string has to be in a very particular order. The keys have to be sorted. And if you know Python, and if you know the tips and tricks that we kind of go through on this channel when using Python, you know that's going to be a pretty trivial thing for us to do. Now, the intuition you might be building is, okay, we're probably going to need some kind of hash map to count the occurrences of each character, because it's not going to be straightforward. Like, look at this. Like, imagine inside of here, instead of having OH, I have O2H. Now, I might think I have 2 instances of O. So I'm keeping track of that, but that's not the final count. I can't just add that to the output string, because first of all, it needs to be in sorted order. I can't just append to this in the output, we have 2 instances of O, because we don't know like which place the O is supposed to go in yet. And second of all, we don't know that this is the final count. After the parenthesis, there could be another number, and that number is obviously going to be multiplied by this number, so it's going to be 4 instances of O. So another reason for why we're going to use a hash map to keep track of the count as we go. Now, before I show you the solution, the final solution, I think it's worth just dry running through this. I think it makes sense, like the fact that we have nested parentheses. I don't think you need to be a genius to know that there is going to be some stack involved. You might not know exactly how it's going to be applied to this problem, but you should hopefully be able to figure out that there is a stack involved. I mean, this is a Leetcode hard problem, and I think in the nicest way possible that if you weren't able to identify that this data structure, the stack, might be useful for this problem, that's perfectly fine. You're a very capable person, I'm sure, but I think you might not be at the level where you should be solving hard problems like this just yet. So now continuing, remember that we could have nested parentheses. So this is going to be the interesting part. This is ultimately the intuition that's going to lead you to the final solution, or at least one final solution. And that is something like this. Let's just create our own example. We have an O, let's say, and then inside of here, I have like an H, and I have maybe another O actually, believe it or not. And then just to make it complicated, let's add some numbers here. I put a 2 here, I put a 2 here, and then out here, I put perhaps another 2. What would the final result of this look like? Well, it's not obvious just by looking at it, so let's actually just go through it. Okay, we have an O, great. We go inside the parentheses. So now we're kind of just forgetting about everything we saw before the parenthesis, because we know eventually, like the input is always going to be valid. We see an open parenthesis. We know eventually there's going to be a closing parenthesis. Don't worry, you're not going to have to do any teleportation this time. We can scan left to right. We see we have an H, a single instance of it. We see we have 2 instances of O. Then we get the closing parenthesis. Okay, great. You might think you're done with everything in here, but not quite. The main reason that we have parentheses in the first place is because there's going to be a number after them, 1 or more. There could be multiple digits. This could be a 20, right? It could have multiple digits. This time it's simple. There's just a single digit. Regardless, though, this is a number that we now have to multiply the count of everything in here. How could an operation like that possibly work, assuming we had a hash map that's counting 1 instance of H, so H over here, 1 instance, 2 instances of O. What do you think we do with this number? Go through every key in the hash map and multiply it. So this will now be a 2. This will now be a 4. Okay, but replay what I just did for a second. How would you have implemented that yourself? I talked about a stack. I talked about a hash map, but we did something kind of interesting, didn't we? Would we have gone ahead and added all of these to the stack? It's going to be kind of complicated if we do that, because obviously there's a difference between a stack and a hash map. But at the very least, we need to know the count of everything inside of here so that we can make that multiplication. But also, what about this boundary? We don't want to take this 2 and multiply it by anything that came before the open parenthesis. So now is the interesting part. And the solution to what I'm saying here is actually very, very simple. The only reason you might not be able to immediately identify it is because you probably have never implemented anything like this before. But there's no reason that it can't be done. Why not keep track of the counts of everything in here separately from the counts of everything that came before the open parenthesis? Because watch what happens later. Like, we want to distribute this 2 here, but I did have a 2 out here as well. So now when all that's said and done, let's just simplify this for a second. Let's rewrite it down here. I'll have an O over here. I'll have here, I'm going to simplify this entire thing. So I'm going to get rid of those parentheses. So I'm going to have 2 instances of H. I'm going to have 4 instances of O. Notice that we can have multiple instances of the same element that show up in different parts of the input. But regardless, now we're done with that part. So now we still have that 2 out here, and now that 2 is going to be distributed. So what happened? What are the problem requirements? I'll try to list them so you might be able to arrive at the solution yourself. The requirement is this: the count of this has to be stored separately from the count of everything that came before. But the count of everything that came before has to also be counted. Like, we have to count everything that came here first. This is step 1. We already counted this, but now we're counting this, and this has to be stored separately from this. Okay, that's another requirement. And the other requirement is that after this second part, and remember that each part is basically separated by parentheses. The parentheses like are here and here and, here and here. After we're done with this, we're going to kind of complete these portions last in, first out. We obviously know this parenthesis is going to be closed before this parenthesis is closed. And once it is closed, look what I have in the output down here. I took these 2 portions, and now they're a part of the same portion. By deleting these parentheses, they are now a part of the same portion. What does that sound like to you? We're keeping track of the counts of these 2 separately, and when we're done with one of them, they become a part of the same portion. The counts at this point should be together. So actually, maybe the way I wrote this, there could have been a better way to have written this. Maybe I could have written it like this: O5H2. What's wrong with that? So now you might be able to sort of arrive at the solution. The solution is that we want a stack of hash maps to count the occurrences of each portion. How did I come up with this? Did I just randomly think of it? No, I had to draw out these examples. When I first started this problem, I had no clue how to solve it. I tried using a stack just to add the characters to the stack, and I realized that that doesn't work, because we have to keep track of the count. That's why we need the hash maps. So now let me kind of dry run through this. There are a few tidbits that are still important that I'll kind of mention along the way. I think the third example is a really good one, so let's do a dry run through this. I'm going to have the stack here. I'm actually going to fill it from top to bottom, so let's just kind of say that this is the top of the stack. So if I pop, I'm going to probably pop from this end. This is going to be kind of a lot to keep track of, so hopefully we don't run out of space. We're going to go through character by character, and we're going to definitely need a pointer I. I immediately know that because remember how to even identify an element, we might need to look at the next character. We know at every point, because we're not going to just shift our pointer by 1 every single time. We're going to look at a specific piece. We're going to go piece by piece, or rather a better way to say it would be element by element. An element is the smallest unit of thing that we're going to be looking at, other than the open parenthesis and the closing parenthesis. So everything other than that is going to be on an element basis. So if that's the case, what are the possibilities? We know if we start here, like the string is always going to be valid. So we're probably going to start with an uppercase character. I don't know if we can start with an open parenthesis, but if we can, our solution is still going to work. And I'll show you why. But right now we're at that unit. We have K. We're looking at it. We want to see what comes after it. It happens to be a number. It's just one number, so that's the unit, K4. In my map over here, this is the first map I'm adding to the stack, and it looks like I'm going to keep it small because right after that, there's going to be an open parenthesis. So I'm going to have K has a count of 4. That's my hash map right there. Next, we get to the other character. It happens to be an open parenthesis. We definitely wouldn't expect a lowercase character. We definitely would not expect a number. How would we ever get a number after we already saw an element? If there's a number here, that must mean that we forgot to add that number to the character. So we never have to worry about the case where our pointer starts at a number. And we also don't worry about lowercase characters. So the only 2 cases for us to worry about other than uppercase characters is open parenthesis and closing parenthesis. So we're only going to need 3 if statements inside of our loop as we iterate over the input string. So as we go, we got the open parenthesis. What am I going to do? Well, what I didn't mention is our stack is not going to initially be empty. Our stack is always going to start with an empty hash map, because we're going to be seeing some characters, and those characters are going to be added to that first hash map. If we see a parenthesis, though, we know these elements have to be counted separately. So let's create a second hash map and push it to the stack. This one will be a little bit bigger. And I'm going to say, okay, just push that there and then just shift to the next character. In that case, we know for sure we're only going to shift the pointer by 1, because an open parenthesis by itself is the unit. Nothing needs to be joined with that open parenthesis. And I guess I'll make this string a little bit bigger. I probably should have done that at the beginning. Sorry about that. Now our pointer is here. We're at an uppercase character. We'll check the next character. It's not a lowercase character. So, okay, at the very least, we know the element itself is O. All we know is that it wasn't a lowercase character, though. It could have been a number. So we might have a second if statement to check if it's a number to know how many occurrences of this element we have. At least that's the way I'm going to code it up. There's just one, though, so we add that to the map, single instance of O. Next character, I'm going to kind of go a little bit faster now. 1 instance of N, going to go ahead and add that to the map. Once again, an open parenthesis. Okay, so better add another map to the stack. Starting to run out of space. Hopefully we make it. And now let's start adding the elements from here. We got an S, add it, 1 instance of it. We got an O, 3 instances of that, so that's pretty interesting. Now we got the closing parenthesis. Now, like I said, a closing parenthesis by itself doesn't mean anything. The whole point of a parenthesis is that there could be a number after it. Well, there's definitely going to be a number after it, and that's going to be multiplied by everything inside of it. Now, there could be multiple digits, so we're going to need a loop to check for that. But either way, we'll get that number. It happens to be 2 this time. So what do we do? This is the interesting part. And I want you to try to figure it out by yourself. Try to pause the video. What we're going to do is, of course, take the number 2, multiply it by the counts here. So I'm going to replace 1 here with a 2. I'm going to try to draw over it. Hopefully it's readable. I'm going to replace this 3 with a 6. That's great. We want to still continue. We now want to get to this closing parenthesis and then take this number and multiply it by everything in here. Now, theoretically, you could do that. How would you do that? Well, take this 2. I mean, on pen and paper, we know that that 2 is going to be multiplied by everything in here, and it applies to everything in the previous map as well, right? Because it's everything in here. We know that looking at it, but how do you think you implement that algorithmically? Because what if we're 3 layers in? How do you know how many layers in you are? Are you going to use a variable to keep track of that? I don't know. It seems like a messy solution and also somewhat less efficient than the solution I'm about to show you. What we're going to do is, now that this section is done, the whole reason to keep track of the counts was for the multiplication, but now we're done with it. So just take all the counts of this, get rid of this, and take the counts and add them to the previous map. There could be some common characters between them, this and this. That's why we're adding them. We're not taking this 6 and replacing the 1 here with it. We're adding it. Now we have 7 of them. And that makes sense when you look at the formula. Didn't I say we can simplify this? We'll get something like this. I don't know how readable this is, but this is 6 O's, 1 N, and 2 S's. And if we were to update this, which I'll do right now, you can clearly see we have 7 O's, we have 1 N, we have 2 S's. Okay, I realize I kind of screwed that up. I probably should have put a 7 here. My chemistry is worse than my coding. But now you probably get the idea. At this point, we're just going to continue. Now we're going to get to this closing parenthesis, and we have a 2 that comes after it. What does that tell us? this too is distributed within everything here. In terms of the algorithm, this too is distributed within everything in the previous, or you could think of it as the current hash map. So I guess I'll try to redraw this over here. Well, O14, N is going to be 1, S is going to be 4. And now these are going to be a part of the previous map, which I'm running out of space. So what I'm going to do is say that we pop this, we add all of this to the map above, and that map would look something like this, where I have K4 and then all of these. And I won't do the chemistry for you. If you want to do it yourself for the intuition, feel free. But this is the result. Like, now we're done. We reached the end of the input. So what do you think the solution is at this point? Well, we are always going to end with a single hash map, right? We have to, because we know all the parentheses are going to be closed. So this is the result. You just go through these keys in sorted order, and then you'll be able to build the output list. Now, one thing I want to quickly mention is, how do I know with 100% certainty when we find a closing parenthesis, we want to like take all of these counts and add it to the previous map, and we want to pop this? How do you know with 100% certainty that there's always going to be a hash map in the stack? Well, the parentheses are balanced, but what about the case where we start with an open parenthesis and I just have like an O here or whatever, and then I have like a 10 out here, or maybe I have multiple elements, and then I take this and do that? On pen and paper, it looks like we're going to take 10 and multiply it by this and then add it to whatever previous map there was, but there wasn't a previous map. Well, that's kind of part of the reason why we initialize the stack with at least one empty hash map, because at the end of the problem, there's going to be one empty hash map in the stack. It starts with one hash map, and it will also end with one hash map. That's because all the parentheses are balanced. Every time with an open parenthesis, we add a stack. We add a map to the stack. With a closing parenthesis, we pop the map from the stack. Therefore, there will be one hash map on the stack when we end. Now, what's the time complexity of this approach? The main bottleneck is going to come from the fact that like we're going to be basically combining multiple hash maps. I don't know off the top of my head exactly how many elements there are in chemistry, but I think there's over 100 of them. So that sounds like it's a constant number, but when you implement the output, I don't know if there is an efficient way to build the output string. I guess we'll try when we get into the code, but I think that this solution is going to be n squared if we have to build the output like that. And depending on how you want to count like the number of unique elements that exist. Now let's code it up. So here are like some comments that I use to kind of arrive at the solution. Now, while most of this code is not going to be super difficult, like most of it's actually not as complicated as it looks, we're going to still need to be very careful not to have any bugs. So let's get into it. Like I said, we're going to initialize stack with a hash map. I'm actually going to use a default dict because we know how overpowered Python is. I'm going to have a pointer I. And while that pointer is in bounds, we know there's three cases we're dealing with. It's going to be the open parenthesis, the closing parenthesis, and the uppercase character case. Now, I'm going to put the uppercase character case in the else statement, because then we don't need to actually check if it's an uppercase character. But in Python, there actually is a way to do that. You could just check the character, and I think there's an isUpper method that you could use if you really wanted to. But let's check now if the character at index I is equal to this or this, and then there's the else case. Now I'm going to start with the first one because that's definitely the easiest one. So when you have an open parenthesis, we know to the stack we append a dictionary. I'm going to again do a default dictionary. Of course, we'd also increment the pointer I, but I'm actually going to put that out here. So I plus 1 is just going to be down there. Next, in this case, I'm actually going to do that after. Let's start with the uppercase character. That's probably the hardest one. Right now, we want to know what the element is. For now, let's assume it's just the character at index I. But it might not be. How do you know if there's actually two characters involved? Well, if I plus 1 is in bounds, we can then read the character at that index. And if that character is a lowercase character, which in Python, thankfully, there is a built-in method. I think you could also do some kind of inequality if you wanted, like check if the ASCII value of that character is greater than or equal to the ASCII value of lowercase a and less than or equal to lowercase z. I know that definitely works in C++. I'm not sure about Java. but we're going to stick with this. At that point, we know that actually that element was not just one character, it was two characters. So what I'm going to do is set it to this formula from I up until I plus 2, but not including that. So this is basically just the two characters starting at I. And let's be careful to actually increment the index at this point, because now we know that now at the next iteration of the loop, we don't want to start at that lowercase character. Remember, we only have 3 conditions. We don't have the condition to start at a lowercase character. We definitely don't want to run into that case. Let's increment I plus 1. Now, the next one's going to be a little bit more interesting. We also want to know how many occurrences of the element exist. Remember how we could have an element of one character, we could have an element with 2 characters, and we could also have an element with 1 character that has multiple, and an element with with 2 that has multiple as well. So there's a reason why I'm putting this next portion after this if statement. Because first we want to just get the element, it's either 1 character or 2, then we want to get the number that goes behind it. So we have to put this after, we have to check if I plus 1 is in bounds and the character at I plus 1 is a digit. If that's the case, let's set the count equal to what? Well, it might not just be 1 digit. It could be multiple digits, maybe 2, 3, 4, or 5. I don't know. It could be a lot of digits. Well, I'm going to do this a fancy way. I'm going to put a string up above. I'm not going to set it to 1. You might first try to set it to 1, but in here, we could have multiple consecutive digits. I want to add all of those digits to a string. That's what I'm trying to do. So I'm in here, I'm trying to say plus, give me that character at I plus 1, and then increment the pointer. So if I start this with a 1, then we're going to have an extra 1 if there are multiple digits. Remember, when there's just a single instance of an element, suppose it's helium, there's not going to be a 1 after it. I don't think I mentioned that in this video, so now is a good time to mention it. We imply that there's a 1. So if we had like multiple elements here, like something like this, if there isn't a number that comes after an element, it's implied to be 1. Here, I'm actually going to set this as an empty string, but down here, I'm going to check, did this loop even run in the first place? I'm going to say if count is still the empty string, if not count, then this should be set to 1. If count is a non-empty string, let's convert that into an integer. Take that string, convert it into an integer, and then assign it here. I guess this is another reason that this problem is an n-squared solution, because we don't know how long that count string might be, and appending characters to a string will rebuild that string, so that's going to be the inefficient part, I guess. Maybe there is a better way to do this, though. I think actually I probably could have just added these to a list and then joined them. I won't rewrite the code to do that, though, because I think it's a minor improvement. Okay, now for the interesting part. We now have the count and we now have the element. We want to take this element and add the count to the hash map at the top of the stack. So I'm going to get the current map from the top of the stack. I'm going to take the element that we have and I'm going to increment the count of it by this variable. And now we're done. Well, we're done with that portion. And that was actually the most difficult. It's going to be pretty smooth sailing from here, believe it or not. So what about the case where we have a closing parenthesis? We know for sure that that's the case where we're going to pop from the stack. So I'm going to do stack.pop here. I'm going to get the current map. And we know that eventually down here, we're going to also get the previous map that's at the top of the stack now, the new top of the stack, like this. And then eventually we're going to take these elements and add them to this map. But first, we need to know what's the number that comes behind this closing parenthesis. Don't we have code to do that down here? I'm pretty lazy. I'm just going to copy and paste. Sorry. So up here, I'm going to copy and paste it. Let's just make sure everything's correct. While the pointer is in bounds, we're going to check if it's a digit. If it is, we're going to add it to this variable, which we haven't declared yet. So let's go ahead and do that. It should be a string. And then we're going to shift the pointer. Okay. Once again, we want to know, was it 1? Actually, I think in this case with a parenthesis, I'm not even sure if there can be a 1 that comes after it, but just to be safe, I'm going to once again copy this line of code, and up here, if it's an empty string, then this is going to be 1. Otherwise, we can convert it to an integer. Okay, now what? Well, first, what we want to do, remember, is take every number in the current map and multiply it by this count. So I'm going to say for element in current map, please take the count of it, which is stored here in the current map, and multiply it by that count that we have up above. So that's step 1. Step 2 would be here to take all of those counts down here and add them to the previous map. So once again, we're going to need to loop through everything here like this, and then we're going to need to say something like this: previous map, take that element, add to it the count from the current map. Now, nothing wrong with doing this, but why write more code if we don't need to? I'm just going to move this up here. I'm going to first take this, declare the previous map up here, and then as we calculate the new count in the current map, which is going to be this, the current count multiplied by this number here, we're just going to take that and add it to the previous map. I'm going to copy this right here, up there, and now we can go ahead and get rid of that. We're nearly done. We're done with this case as well. So we've practically solved the problem. The only thing that we want now at this point is, after everything is done here, we know the stack is going to have one hash map left. I'm going to call it the count map. I guess we could pop it, or you could just get it. But we want to build a string. So I'm going to declare a string here. I'm going to initially set it to this. And then I want to go through every element, which is a key in the count map. But remember, I want to go through them in sorted order. So in Python, very, very easy to do that. Just get the keys and then sort them. And so now we're going through them in sorted order. Now, you might think you can be lazy and you can do something like this: add to the string the element with the count of that element, which we can get like this. Let's say count of that element is this, count map, just like that. And then down here, convert it into a string, and then concatenate that string as well. You might think you can do that, but you might be forgetting about the case, and I forgot about this case. What if the count was 1? Well, in that case, we wouldn't want to concatenate any string here. So up here, I'm going to once again have a ternary operator, just like this: empty string, if this equal to 1, else set it to the actual count. So just going to copy that. Okay, that is the entire code. And actually, without the comments, it's not super long, 37 lines of code. Well, actually, to be honest, it is pretty long, especially with all the shortcuts that I took. I want to quickly mention, though, that like if any of this is confusing to you, like the Python stuff, that's understandable. I'm using some advanced techniques. But in like 1 or 2 days, I should have a course out that literally teaches everything that I just talked about. And it'll give you a bunch of like practice problems to practice your skills and stuff. But this is the code in its final glory. Actually, I forgot one character down here. Instead of key, this should be keys. Sorry about that. But now let's just run this to make sure that it works. And here you can see that it does, and it's pretty efficient. If you found this helpful, you might be interested in some of my courses. By the way, that Python for Coding interview course will be available to all Leetcode Pro members as soon as it comes out, all existing Leetcode Pro members. I try to be loyal to you guys and provide as much value as possible. So thanks for watching, as always.